I would like to introduce Stefan Svahn. He is the CEO of Synthetic Data Solutions. And that company has the same founder as Embeddle, and that is, of course, Hans Salomonsson and Devdat Davadushi, who is here with us today. It's a sister company, if I put it that way. So Stefan Svahn, now I think I have spoken enough about this because you are the expert. I would like to understand by the end of this day if it's possible for me to actually have a digital twin. And then where would she be right now? What would she be up to? Could you clarify this, or would you only like to just clarify and introduce the speakers? Looking forward to the session and to see the outcome of this. Welcome.
Thank you very much. Yes, so we have 1 hour session within synthetic data and digital twins. It's afternoon. We will try to make this as concrete and as applicable as possible. I'm not sure if I can give you a date for when you can have your digital twins, Cecilia, but try our best. The first part of this session, I think it's good to give each of the panelists and myself around 3-4 minutes to make a self-presentation. So the audience knows a little bit from which industry we're coming from and our experience relating them to digital twins and synthetic data. I think if you compare it a little bit to earlier sessions, this session with its topic of digital twins and so on, I think it's a little bit different because we have so many different industries having their views on this, and I hope this discussion will be as versatile as possible, looking at and trying to explain digital twins and synthetic data and its applications among different industries. So with that said, I'll start off with myself to present for a couple of minutes here. I'm the CEO for Replify. We recently changed our name. Earlier, our name was Synthetic Data Solutions. We are a startup based in Gothenburg, and this is the second company I'm running here in Sweden. I'm not from Gothenburg, but I had my fair share of Gothenburg. I've been studying here at Chalmers. I have my master's degree from here, and after that, and working with my first company, I moved to Hong Kong and got an interesting experience working within the APAC region. I've been in India a few times as well. But then coming back to Sweden a few years ago, that's also when I got into Replify, the company. So what do we do then at Replify? We have a technology where we have automated the process of creating synthetic data used also for digital twins, of course. And synthetic data has a lot of advantages. I'm not going to go through them now. But I think one should also be aware of that it actually costs time and money to set up a digital twin and get very accurate and relevant synthetic data. And with Replify, I hope that could bring down both cost and time for many companies to get and iterate towards good synthetic data. We're talking about 10 times as fast as conventional methods, sometimes up to 100. So we believe this is an important building block within the whole digitalization area and also within the use of synthetic data. I also want to mention that we have a partnership with Volvo. We're sitting at CampX, and we're very proud of that partnership, of course. And we also have a roll-up outside where it says Replify with big letters. So if anyone is interested, please come by and talk to me. I will be there during the breaks. But that's enough of me. So maybe we can start with the physical panelists, and then we can go to the remote ones. So Ganesh, would you like to continue?
Thank you, Stefan. Very good afternoon, and hello everyone around the world. My name is Ganesh Booker. I represent Wipro here. As you all know, Wipro is a global IT consulting and R&D and a system integrator player, catering to customers around the world. And my role specifically is I'm responsible for Wipro's Industry 4.0 and sustainability business globally. What is my part specifically around digital twin and synthetic data is today we work with about 20 different industry verticals, from automotive to healthcare to consumer to smart cities, building platforms of scale, helping them to be on the digital twin journey. And again, data is an essential part of digital twin journey. So I'm going to share some my perspectives of how we see this, how customers are realizing this benefit, and also where the struggle is and what challenges we are helping them overcome. Over to you, Lee.
Lei.
My name is Chen. I'm working at the RISE Research Institute of Sweden. Probably some of you know.
Yeah, sorry for that. Technical issues. Probably some of you have learned RISE. RISE is Sweden's innovations partner, also research institute. It is owned by the Swedish government, and we have now around 3,000 people working all together to bring the sustainable solutions to the world. Our mission is very clear. We work with the academics, we work with the industry, we bring the research together with the industry productions, products and services into societal impacts. That is our mission, and also the mission from the government. So we have around 130 test beds in Sweden, owned and co-owned with our partners. We have the major application areas, basically cover all the areas, including mobility, digital health, digitalization, automotive, even agriculture or chemistry. We basically work with most of our across all Sweden with the local stakeholders and also international stakeholders to bring the solutions. So today I'm more from the transport and automotive perspective to discuss a little bit the digital twins and the synthetic data that could be used to enable future mobility solutions that be much more safe and efficient, emission-free, and also, last but not least, comfort for the people to travel. We're talking about mobility services. We're not talking about vehicles in the future. So I hope that will be something, since we are also part of the Swedish-Indian transport traffic safety platform CITES. We have been working with quite some Indian partners to look into the traffic safety issues in Sweden, in India, and how we bring the Vision Zero from Sweden to India. Together with the industry partners, so Volvo Trucks and also Ericsson, and also the local stakeholders in India.
Thank you, Lei. Shall we go over to the remote connected panelists? Shall we start with you, Erik Jeansson?
Yeah, thanks for having me at this conference. My name is Erik Frankson. I'm a geodata strategist at the City Planning Authority, the city of Gothenburg, Sweden. I'm also project manager for Virtual Gothenburg, or work with digital twin. And personally, I've been working in this GIS industry for about 20-25 years. First 10 years in the technical consulting industry, and for the last, say, 15 years in the city of Gothenburg as a GIS manager and now geodata strategist. And I can say my work include making geodata a well-known and used information source in the city, and to make Gothenburg a smart, resilient, and sustainable city by the use, of course, of geodata and digital twin. And In our digital twin project, which we call Virtual Gothenburg, we're trying to develop a twin for maintenance and the planning and controlling and perhaps even experience in the city. And we see that all departments in the city are involved in this project in some way. And I think that the twin will be an important tool for addressing the societal challenges like climate change adaptation, like a virtual lab for future climate neutral city that we all work with, and perhaps a common platform for citizen dialogue. We heard this word metaverse before, and perhaps regarding urban planning, then the citizen dialogue. And we also see that the Virtual Gothenburg digital twin is, we could call it a driver for innovation and data management and also decision support for the politicians. And as for the theme of the day, we also use synthetic data for example, traffic simulation, like testing autonomous vehicles in a virtual environment, where we can create different scenarios with populated models of pedestrians, for example. And we also make scenarios regarding heavy rain and flooding, which are also based on, you could say, synthetic data from models of future precipitations. So there's a few examples how we work with the digital twin, Virtual Gothenburg. Thank you.
Thank you, Eric. Shall we move on to Anand?
Hi. Thanks, Stefan. Good afternoon, everyone. Anand Chakravarty here, right now from the Netherlands. I'm extremely happy to be here because I've lived for 4 years. I think the better way to say it is I've experienced 4 Swedish winters before I moved here into the Netherlands. So I'm extremely happy to be a part of this forum here. I work with Tata Consultancy Services, and in my role today, I lead our engineering practice for Europe. As a part of this practice, what we do is work with a lot of solutions, work with what is technology and how we look to innovate the engineering and the product development space. That extrapolated now into what we call the areas around the digital twin, the digital thread, etc., is primarily the focus as we're seeing it going ahead. TCS, of course, has invested a lot in this space. We've got our own platforms in this area in terms of analytics, because the digital twin does generate a lot of data, and we've got to have frameworks and tools that allow you to help actually make sense of this data and connect it across multiple cases. We worked with a few examples around which we worked is, for example, digital twins of plants as a part of smart factories, or digital twins of boilers or windmills, which allow you to, remote monitor as a start. But we think there's actually a lot more applications of this, just like Eric was saying earlier, into digital twins of cities, into digital twins for processes and multiple other areas. So looking forward to extremely interesting points of view from this panel here.
Thank you, Anand. So, Anders Logg, would you like to take over?
Yep, thank you very much. So my name is Anders Logg, and I'm the director of something called the Digital Twin Cities Center, which is hosted here at Chalmers. So this is a national competence center working with digital twins of cities and also larger regions. So this is a center where we gather around 30 partners from Swedish industry, Swedish municipalities. We have some international collaborators as well. And we do research in all things related to building digital twins of cities. And that's all the way from mathematics and computer science, so mathematical modeling of a city. How do you, for example, simulate things in the best possible way? How do you build the best possible data models? How do you visualize the results for different purposes, different audiences, and so on? So it's quite exciting because we have this very diverse group of people coming from all over Chalmers all over Sweden and getting together with the intention to examine how to use this concept, this new technology, and also develop new technology for digital twins of cities. My own background is that I'm a professor of mathematics here at Chalmers, and my background is in computational mathematics, so large-scale, high-performance simulations, development of algorithms, methodology for that. And you could say it somehow relates to digital twins because this simulation aspect needs to be part of the digital twin. That's sort of, that's why you can ask, I mean, if you have a digital twin, you want to be able to ask questions. So what happens if? And for that, you need the modeling, you need the mathematics, you need a simulation aspect. But digital twins is more than simulation, but my background in this area means that, I mean, I see that my background, my expertise also has some bearing on this area. So it's exciting to see how the methods that we work with can serve a purpose within the area of digital twins. And also working with all these other research groups, all these other disciplines makes this very exciting. And also, I mean, also feeling this very big drive now coming from all over the industry, from the municipalities, the public sector, for creating and building digital twins. That's my background, the Digital Twin Cities Center here at Chalmers.
Thank you, Anders. And I also share your feeling there. You mentioned in the end that it feels like, I mean, digital twins has been talked about for a long time, and now it feels like things are really moving here on different applications. So, but just to get, we have a broad range of people here in the audience as well, and from different areas. So I just want to start very concrete. What is synthetic data and what is a digital twin? And I can give a simple version from my perspective, and then maybe you can take over and broaden it a little bit, Anders. And I mean, in my view and Replify's view, a digital twin to us is basically that we can take an area of land, a landscape or a road network, let's say, and we can make a digital copy of this. Basically, you have a copy of it in the computer, you can simulate it, you can walk around it and so on. So, but what differs synthetic data from a digital twin is then that you can, in the computer, in the same context, you can actually create roads, for example, that doesn't have a real counterpart. They don't exist in reality. And that's, while it's similar to a digital twin, but it doesn't have a counterpart. So that's what we see it as synthetic data, basically. And under certain restrictions, I mean, you cannot totally randomize stuff because it might not appear natural, so to say. So it has to be within some kind of borders to appear real or appear relevant in whatever way you want to see this. So that's a little bit my definitions of synthetic data and digital twins. Do you have any? Can you extend that a little bit, Anders, for example?
I mean, this is something. I mean, this is digital twin is kind of an elastic concept. I mean, this has been around for about 20 years in the manufacturing industry. This started out. I mean, you have a product, you want to build something, and then you have a very controlled environment. You're building a car or an engine or something like that. Then you can create a well-defined digital twin in order to model, optimize this thing. You can also build a digital twin of the factory and the manufacturing process in order to optimize that and make it as good as possible. When it comes to cities, this has been around for about maybe 5 years. This was sort of exploded in the last 5 years. But I mean, I think even if different groups have different definitions, and I mean, this comes from the fact that you want to say that you have a digital twin, right? Because this is a new buzzword. So if you have something, then you say, we have built a digital twin. We have a 3D model. It's a digital twin. We have some sensor data. It's a digital twin. But if you want to be really strict, I mean, then you need to have all these aspects. You need to have a 3D model. You need to have the connectedness. So the digital twin should reflect reality as it is now. I mean, it should not be a model, an offline static model of something. I would say that is not a digital twin. It needs to be connected, it needs to be live and mirror the physical city or the physical object or system. So this thing about the 3D-ness, being able to experience it in different ways, going into it in VR or AR or on a screen, that's one thing. Another thing is the connectedness, which means, for example, that you have sensor data that feeds the digital twin with new data all the time. So those two are important. And I would say the third one that is important is that there's some kind of mathematical model, something driving this, meaning that you can test new things. You can say, what happens if I build a new bridge here? What will happen then with the air quality, with the traffic patterns and so on? So these three aspects, the 3D aspect, the connectedness, so sensor data, and third, the modeling and simulation aspect. So I think those three are essential in order to have a sort of full digital twin. And in the literature, there are various definitions that go around, but all of them try to somehow capture, I think, these three aspects of digital twin. But then, as I said, it's an elastic sort of definition, and people use it to their advantage, I could say.
That's a really good explanation. I think it makes a lot of sense. And also another very concrete thing that could be put in this context is that the digital twin doesn't need to look visually like something. It can be a twin in aspects you can't see with the eyes. It doesn't need to be actual facades of buildings. It can be electrical network in a city and so on. So just adding on. But I also want to hear your point, Anand. You mentioned something that you worked on that you called a digital thread, if I'm right. Would you mind just briefly mention what that is?
Sure. So I think picking up from what Anders had mentioned, the differences between a model and a twin, adding the elements that he had mentioned. The models the digital twins are multiple. So in the sense, you said it doesn't have to be physical. So in some sense, it's something you see, which could be a design twin, which means it's something that you've designed and you can look at. There's a digital twin of something that's a physical asset, which is also feeding in data from sensors and things like that. You've got process twins, which help you do something like optimize a factory or look at traffic layouts and then simulate around it. What we look at from a digital thread perspective is that there are these multiple aspects of starting from design, moving on down the line till a physical asset and how you see it. But the data that comes in from all of these areas also need to be sort of connected and given in the right perspective of the domain of these different users and the different people who see it. Establishing that as an underlying layer for the digital twin is what we're calling the digital thread. So there's a lot of digital in that, in all of that, but it's in essence being able to take this closed loop, what we call this feedback, and data coming in from the field on a turbine, for example, or traffic data, put it back into context of the people who've worked on the system of the traffic lights versus the people who worked on maybe a cooling system of a turbine versus somebody who's worked on the installation of something like that. So putting it in that context and making that connection is what we refer to as the digital thread.
All right. Do we have any other comments on that, or shall we move on to the next?
I could have one comment to the. Of course, I agree to what Anders and Anand said, as I'm working with Anders as well in the building of the virtual digital twin of the Gothenburg. But I see also that, of course, it's a copy of something of reality and connected data and services and real-time data, of course. But it could also perhaps be used a twin that you say take actions with the help of AI. Regarding on the input that you have, so that the twin actually acts in the same way or in another way as the reality. And for the case of Gothenburg, the city of Gothenburg, we don't see it as one digital twin, but several digital twins, which are made for multiple purposes, for multiple needs. So I think that's important to see that it could be many digital twins for a city.
Yeah. Exactly. Before moving on to the next topic about the challenge, I just want to also make clear some of the general advantages with synthetic data or digital twins. Is I mean, by having something digitally in a computer, you can simulate it, you can test it, you can stress test it, you can modify it without needing to have physical counterparts and so on, or need physical test beds and set up any physical test people and so on. So I mean, that's all general advantages with the digital twin or synthetic data. But so coming into the challenges today, because there are probably a lot of different challenges depending on which industry you are in, which application you're looking at. And so I would like to ask, before I ask you, Lei, I would like to ask Ganesh, because you mentioned earlier when we talked about a survey you had made,
Yep.
that company are happy to say that they have transferred or using digital twins, but it might not always be the case, and it might not be relevant, so to say. So
Yep.
Please enlighten us.
No, absolutely. So, like I mentioned to Stefan, so we ran a poll very recently with about 500 customers of us globally on where are they on the digital twin journey, and how do they see this panning out for their enterprise. So what was tackling is, again, a digital twin ultimately has to enable business outcomes, like Eric said, driving autonomous in the way of decision making. So in the journey towards driving autonomous decision making, there are multiple phases or steps. The first one is digitization to enable digitalization. So digitization, then remote monitoring, then remote control and collaborate, and then finally driving the autonomous operations. Starkingly, about 60% of customers said actually they're still in the step one of digital twin, which is more of digitization. And and almost another 20-30% said that they are probably in the remote monitoring phase. So like sensors we talked about. So this is very important as to how you tap into the multiple building blocks. And that's where the synthetic data angle comes into picture, because a lot of customers or a lot of industries are overwhelmed in the first step itself, because you have a lot of unstructured data, documents, and first is to get immense value out of that. That step is the digitization process. So how do you tap in technology for that? The second part is obviously driving in sensors, gathering data, acquiring data, simulating it, and scaling the data. That's the second part. In a way, obviously, any digital twin platform, in our experience working with automotive or with other industries, capital equipment industries, key is the digital twin configurable? Because the use cases will evolve. So there is no one definite endpoint for a digital twin. So is it configurable? Is it reusable? Because you need to build components which are reusable. The third part is it scalable? And the last and most important part is it explainable for every user in the value chain, right from your operator in the shop floor to your CXOs? Everybody should be able to visualize the same digital twin and draw inferences. So configurable, adaptable, reusable, and explainable. So these are key aspects when we think about digital twin. And that's something that we are trying to now put into our solution to offer.
Yeah. When you say it doesn't, it sounds really complicated actually when you drill down to it. To have if you want to have a digital twin of a product, you really need to have it in its context as part of it. You need it to be, let's say, connected. If you are going to look at the whole system, it's so many parameters that can affect each other. So I guess it's not easy to get a good digital twin, so to say, working in complex situations. But that's just my own reflection. I'm moving on to you, Lei, because you had some interesting to share when it comes to the infrastructure that's needed for digital twins, or maybe it's more related to mobility and have that autonomy level up. That has been mentioned earlier today. Is a lot of data being communicated, and you need a good short latency and so on. would you like to describe a little bit of that challenge that we have also regarding infrastructure today?
Yeah, thanks, Stefan. Yeah, that's exactly like you already said. And from the system levels, we have so many different systems that already a challenge today in the physical world to connect those systems, to let them work together, and going into the digital world that add another layer of complexity. From the infrastructure perspective, we are going into the connected, automated transport system. We need a digital infrastructure, road infrastructure, communication infrastructure. We have been discussed this a long time. We have the connected vehicle technology since the 80s. And yet we haven't used them in reality. Yes, of course, our cars are connected into the mobile network. Then what? You get the entertainment systems, how that is going to help improve the traffic safety. And we have the traffic safety communication connectivity solutions now. And then it ends up with the discussion, debate regarding the technologies, and infrastructure is not fully supporting those connected vehicles. And then it's reached a point that we have all the technical pieces there, and our road has a lot of sensors, and the sensor information is being collected, but we haven't managed to put all those things together in a digital twins, let's say. If we have such a digital twins, we have the physical world, we have the digital world. Digital world and the physical world are connecting with each other. And then we are able to actually provide really good traffic safety applications. The infrastructure can warn the cars. They can detect dangerous situations. They can detect the pedestrians at intersections and warn another car. And there are, of course, some pilot studies today, but we really want to make those things to reality, to everyday life. When you drive the cars, you are sure that you get support from the infrastructure digitally. And that information can be used to improve traffic safety. And of course, at the same time, to provide you with good services that you enjoy your journey, you enjoy your mobility. And we would like that into the mobility services. Instead of you drive your own car, you could take the autonomous vehicles in the future. You order it, and you have all the services with you. So that is the things we're trying to reach, but not yet. Which I think today is probably a lot of challenges we have discussed is that the challenges we need to solve before we can reach that point.
But it's on its way, I guess, this infrastructure,
it is
or how is it?
On its way, and in the last, I would say 10 years, we see the increasing technology advancement of autonomous vehicles, and we see 5G is coming. We are seeing the implementation of 5Gs now, and 6G is also on the table under discussion. Massive IoT is part of the 5G discussion. We will have billions of sensors. Basically, all the things that could be connected will be connected. And the next steps, all the things that are connected could be used. The information from those sensors, not just the connected. We need to use the information from the sensors, use the data, get the value from the data. And we cannot do that alone. We have to get all the stakeholders together, because in the physical world, we have a systems. In the digital world, we will have a digital systems. And that is not a single stakeholder that can solve the whole piece of puzzle. And we all need to work together. We need collaborative protocols between the organizations, between the humans. We also need the digital protocols, the communication protocols that is defined by the telecom, of course, but the interaction protocols. How do we represent the data, sensitive data, for example, and how do we communicate with different technical systems.
Yes,
That is
exactly. I mean, it's very clear to me also from the ADAS session. I mean, it's clear that it's so many, let's call it sub-industries that kind of need to move ahead together. I would say I would like to hear a little bit from Anders or Erik from let's say a city perspective here. Is it any infrastructure that's limiting, similar to the mobility part, or what's the challenges on your end?
Perhaps I could start with that. I think just the democracy aspects are very interesting. Working with the digital twin as a platform for democracy and citizen engagement, dialogue, and kind of transparency from the city to the citizens. For example, we work with urban planning process from early strategic planning to the detailed planning. That is involved several steps and several steps regarding citizen dialogue. I think it's very important that citizens, of course, are involved in this process. Or to understand city planning projects, I think visualization and digital twins preferable is essential. By using a digital twin, it's possible to understand this development in an understandable way. So you can walk around the planned neighborhood from a street level. Perhaps you can add thoughts about the proposed plan or projects and post them into this environment, in a virtual environment, so that other ones can see what you have, what your ideas are. And I think this makes this kind of dialogue process more transparent and perhaps faster and more economic. You could, in the end, get better results in the urban planning by involving the citizens in this way you can do with the digital twins.
Yeah, it sounds like it's in the digital twins in city planning aspect, or let's say the dialogue democracy aspect, that it will be more transparent. People will actually know what's going on in the city. I mean, yeah, exactly. I know also myself. I wonder what they're doing in these construction spots and so on. That it's to people. I don't think it's clearly to know where can I get the info, what's happening around the corner. Okay, I'm moving on here. Time is running. Then I also would like to talk a little bit about the differences between India and Sweden. Also, as part of this event, and it can be differences, for example, in, I don't know, focus. What type of applications are most common, let's say, when it comes to use of synthetic data or need of synthetic data and digital twins. It's open for anyone. You just let me know if you want to answer this. But maybe Ganesh, do you want to have a comment to that?
Yeah, I'll go first. And there are two aspects to it, Stefan. One is the India-Europe collaboration or India-Sweden collaboration specifically on this. And again, Wipro has been in Sweden for almost 2 decades now, working with the manufacturing industry, utilities industry, and the aerospace and defense segment. So there's been a lot of talent and interaction between the universities here as well as the industries in terms of tapping into the technology investments that are happening and driving innovation, and especially with enabling smart factories in some of the factories around Sweden. And how do you thrive on innovation? How do you drive AI in building best-in-class quality, whether it is the defense research organizations or with the traditional manufacturing? So that's something that we have seen significant success between the India-Sweden collaboration. The second aspect of the part in terms of synthetic data is there are several examples. Again, let me touch upon one of that in the retail. And since we've all experienced in the last 18 months with COVID, the whole supply chain has been a bigger challenge for all of us. And today, worldwide, we are seeing that logistics is strained. So whether it comes to pharmaceuticals, where we are talking about vaccinations, or with the overall retail supply chain, we built a digital twin for one of the largest retailer in the world. especially on their warehouses, because how do you plan for certain unforeseen situations? Now, obviously, you have a physical model, you have a digital model, you have scenarios which you are explainable. But the role of synthetic data comes into picture when you have several environmental factors which are noise, which you cannot control, but it will happen. And COVID was one such scenario. We saw the blockade in Suez Canal, which is something that nobody predicted. It's been so long, and we still see those effects. So we built a predictive model for one of the largest retailer with weather storm patterns, weather conditions that could trigger actually in somewhere in Far East, which could actually apply to the ship or a flight landing in North America or in Europe, and how it will impact a truck that gets delivered on the distribution center. So that is where synthetic data comes into picture, because you know use cases. You have data sets which are defined with certain boundaries, but we brought in a technology of AI powered by knowledge graphs. So we built data patterns across various actors in the ecosystem. And we heard that in the previous session also. Understanding the ecosystem of what are those actors and how do you model and how do you build a pattern. And that's where semantic data, knowledge graphs actually help you in creating an exponential volume of synthetic data that makes the digital twin robust. And today, when it comes to Thanksgiving, we can really plan how many trucks will be at the doorstep of the distribution center, how many workforce that is required, which segment of the region will get delayed because of weather patterns, could be something else. All of that is actually doable, and we have done this. But it is how you enrich the data, and that's where the role of synthetic data comes into picture.
It sounds impressive, really, to keep that many parameters.
It's crazy, I would say.
Yes, I also thought about asking you, Anand. I mean, as I understand, I mean, having experience from India, working in Europe, what's your take on this? I mean, looking at differences between the Sweden and India regions in different aspects.
So let me go towards the sort of differences and where the converges potentials for collaboration. I think a very good example is of which you are actually a very good example is the strong startup ecosystem that that exists in Sweden. There's also on the forefront of digital, on the forefront of what we're talking about here. We've got the 5G technology and other things also which Sweden is playing an extremely important part. If I overlay that with with the larger digital journey that even India is looking at with a different flavor, I think one big thing that we could see here is that there is scale over there. There is a scale when you look at city planning, when you look at autonomous, when you look at all of this. So in terms of both synthetic data as well as in terms of real data and live situations, I think there's a lot of application possibilities. In addition to that, I see that as a general area, India is a large global technical hub for talent, and what that means is an ability to also tap into what is through sort of a hub and spoke model, looking at India as a way to tap into what's happening in multiple areas. And we've seen examples of it, and whether it's something happening in the US or in Japan, and find a way that, that can be a collaborative effort coming back in a more Indo-Swedish context. That's I think how this is probably going forward towards a convergence and areas of where we could extend the collaboration, in addition to, I think, a lot of work that's happening today with, for example, water management, smart cities, waste treatment, etc.
Yes. Thank you, Anand. I move on to the next topic here, just to keep up with the time schedule here. And then I think it would be good also if we can have some good case examples of how digital twins or synthetic data can improve the current technologies. I mean, a little bit concrete here. Do we have any good examples of where we actually can use and can see the improvement of using digital twins in different applications? I'm asking you, Anders, if you have any views on this or any good examples.
I think, many of the things we can do when it comes to digital twins is something that you can do with other technologies like simulation. You want to test something out. You run a simulation, you build a test case, you run a model, and you get some results, and you act on those results. It's not really a digital twin, but it's a model and a simulation that you can get results from. But the thing that Eric mentioned is that this becomes, you raise the level of this when you put this into a digital twin. You add the element of visualization and get this into an immersive experience where the citizens, for example, can see the effect of something. So that's one thing where you can say that, okay, you don't just run a test case, but it's a live test case, and you can experience it, and you can view the effect of things in this environment where you can recognize. So, for example, I know Eric has made a very pretty visualization of an area in Gothenburg called Linnégatan, where you can walk around and you can see the bus stops, and you can sort of even see perhaps the timetable for the buses. It's that level of detail. And that's something that we work quite a lot with, where we run simulations and we put those into the context of a visual or acoustic experience. And in that case, you don't even need to run the simulation on the same data. You can run a simulation, you can do a modeling, which you do on a low level of detail digital twin. So it's a simulation done in the way that you would normally do a simulation. But then you put that into the context of a very pretty photorealistic, almost 3D experience. And you sort of make the data come alive, because you can touch it, you can feel it, you can smell it, you can see the data in the context of the model that you're working on. Otherwise, it's just sort of just graphs on a computer screen. But now you put it into it's almost like you can put the data back into, and the simulation results back into the real world, because a digital twin is so close visually. Yes. I think that's one of the main things with digital twins, is that you can experience data, you can experience simulation and modeling results in new ways that give you more insights than just doing a static simulation and you look at some results. So I would say the one of the main benefits is this ability to experience data and experience results, which gives you, you can make more informed decisions when you understand the data better.
Yes, it's very interesting. And before you continue, Eric, I'm just wondering, working with this digital twin of Gothenburg, is it available now, or is it when can we see that or experience that?
It's not available yet, but we said that in December this year, it's just 1 month, it will have a first version of the digital twin, but that will be in-house. We are planning on delivering some parts of it as open data, for example, the 3D information, but just, you could say some basic information, not rich information, but that kind of release will be sometimes next year, I think, with 3D data. Yeah, but not the full digital twin experience.
Yeah, I'm really looking forward to that, to be honest, to see some really concrete examples here. Did you have anything else you wanted to add, Eric, to Anders' comments? By the way,
yeah, I can perhaps add this kind of the society is so complex today, and the challenges that we have, climate change, so on, that we have used new methods to approach its challenges. And we talk about this kind of multidisciplinary methods that we see architecture, traffic planning, energy solutions in one single model. For example, as Anders talked about making a car or a product, it's the same way. You must see the entire city as one organism, so that you can handle this kind of modulation in that organism. So this kind of model, a multidisciplinary method, I think is very interesting to work with in the digital twin technology.
Yes. I'm moving on a little bit here, and Anand, correct me if I'm wrong, but I remember you had some interesting examples from your end where this has been applied, if it was within shipping or any other thing. It's enough if we just mention one example before we move on.
Sure, I'm conscious of the time too. Yes, I think a good example would be what we've done with more like, in the sector of power plants, where we're looking at these are extremely asset intensive industry where it is important to know how the asset performs. So in a multi-level, creating the digital twin of the asset as step one, followed by creating the digital twin of the process, which then results in what we say the digital twin of the overall plant. Now, what this allows us to do is everything that Anders was saying earlier. Is you've got data that's coming in. It allows us to look at seeing how you can actually tweak this better. You can see how you can improve performance. So you can create performance twins out of it. You can look at it as a feedback into the design of these systems. And not to mention the fact that all of this in a simulation mode, it does help tremendously. And what we've helped these plants with is save millions in terms of the time it takes to, for example, do a setup, the time it takes to do an installation, because you do now have a model with live digital data from otherwise experience to simulate these and see what happens when things change. The applications of these, especially when you see it from a power area, is actually quite phenomenal, because it has its impact on sustainability. You can actually tweak it and see what happens with the different situations and how you would actually affect emissions. What would happen if you had a power surge, and how a traditional power source would behave to it in terms of what it does to a boiler, what it does somewhere else, and how's the best way to optimize these, etc. So that's sort of the whole thing. And it does, of course, need an extremely strong underlying layer of analytics. And the next level that we're looking at now going with this is using automation and AI, so that we can start making these models a little more autonomous, which is towards where the future is. So one is to use it, look at it, and the second is then enable how it starts getting more autonomous about it.
Yeah, thank you very much. And now we're time is almost up, 5 minutes, and I want to end this with the last question. So please be brief, maximum 1 minute answers here, and that's a little bit where each one of you see the future, let's say 5-10 years from now, within digital twins and synthetic data. I mean, it's easy to be naive to think things will come fast, but in reality, everything is waiting for all components to be there and so on. So quick answers. Maybe we can start with Ganesh and then Lei, and then go to the remote panel.
No, obviously, my goal or vision would be in 10 years from now is a factory that can operate autonomously, which can build what is minimalistic with minimal carbon footprint. So
yeah,
it's autonomous manufacturing, which could be driven with all of these technologies.
All right, Lei.
5 years or 10 years, I think we are having a boost from 5G and metaverse now. We will see the rapid development of digital twins in the coming 5 years. That is basically for sure. 10 years, I will be really expecting autonomous cars and autonomous transport systems will be reality, at least partially. That we will see the infrastructure and the vehicles and the even flying cars we are working on also, that all connected into this urban mobility systems. That will be exciting.
Yeah, I'm looking forward to that as
well.
Okay, moving on here. Anand, do you want to continue?
Sure. I think what we're going to see here in this space is more adoption, more automation, and more data. And what that's going to mean in the longer term is things are going to be different. This is going to allow us to do more in terms of completely newer business models and ways of doing things compared to how it was before. Today, we've not yet. We are just beginning to see the effect of what a digital twin does. Examples, earlier in. it's really going to open up the way that we start doing things extremely different. And that's what we really have to look forward to.
Yes, thank you, Anand. So moving to Erik.
I don't know exactly about synthetic data, but of course we are modeling the future in some way. Like we need a climate lab. We're talking about to testing and visualizing climate change adaptation, and like the example from the Neargatan Anders mentioned, like storm surge gate to the sea, and we have to work with some kind of data to make this kind of models. But also see, we talk about metaverse, which is the buzzword perhaps, and everyone is talking about, but we actually see that this virtual worlds could be some kind of backdrop or platform for visitors or for the citizens themselves to meet and to perhaps go to concerts and that kind of things when we can't do it in the reality on the pandemic. So it could be the future of the digital twins morphing into some kind of metaverse.
Yes, interesting. Anders, last out.
Yeah, I think Anand mentioned something important. He talked about automation, and I think this is something that needs to happen when it comes to data. Automation of the data gathering, data processing, because these digital twins that we talk about now, all of them require quite a bit of manual work in building them. You have to collect data, you have to convert data, and maybe even model 3D buildings by hand. So this automation process where the digital twin happens automatically, and it's all the time in sync with reality, because all the processes of creating it have been automated. So that's my vision, and I think one of the most important things, so that these digital twins that we build, they become sustainable. They update themselves. It's not a one-time thing that you do to make an impressive pilot, but they keep updating themselves. So the automation of the creation.
Yeah,
I think that's one important aspect.
I think that's a very interesting aspect of this. I think now we got everyone's answers, so I will thank you very much for a good discussion. I hope you enjoyed, the audience. So thank you very much.
Thank you.